using Cauchy-Riemann equation. Alright, so let's find out the value of u and v. Right? So u of xy is e to the power of x cos y, and v of xy is going to be e to the power of x sin y. Okay? Right? So in order to determine Cauchy-Riemann equations, you must have del u over del x must be equal to del v over del y. And then we must have del u over del y equals to minus del v over del x. Okay? So let's verify the first one. Del u over del x is how much? E to the power of x cos y. And then whether this is equal to del v over del y, e to the power of x cos y. Just differentiate this. So that it works. Here, del u over del y is minus e to the power of x sin y. This one is minus e to the power of x sin y. So are they the same? Yes. Okay. So that verifies that this function is additive. Part B. Yes, any questions? Any questions? Sorry?
More than 6.5. Unfair more than 6.5. Too much working.
Let's see whether you can do it except
So you must be debating.
Tahu, saya tanya tak kena buat macam tu juga untuk nak makan. Benda saya tu macam kau buat cuba tengok macam boleh tak? Analitik macam tu.
Part B, evaluate the line integral in the complex plane. So you have the integral over C, the real part of z squared, dz. So this is just like a vector. Okay? Here you have the complex multiplication instead of the dot product. That's all it is. Okay? So this is like your f of RT. And this one is like your dot with R and T. Okay? That's all it is. Okay? So when you multiply here, you multiply complex numbers. Okay? You cannot use dot product, so now you have to do with complex numbers. That's the only difference. Okay? So let's look at how to solve this problem. You have a circle is given by the circle in the complex plane with radius 1. So the parameterization of zt is equal to e to the power of it. Okay. This is the parameterization of the unit circle in the complex plane, and t goes from 0 to 2 pi. Okay. So you need the derivative of z. I times e to the power of it. That is the derivative of z. Then we need the real part of z squared. So what is z squared? So zt is e to the power of it. So z squared t will be equal to e to the power of 2it, right? Just square it. Okay. Now you need the real part. So you have to write this in terms of the real part and the complex part. So write it as cos of 2t plus I times sine of 2t. What is the real part? So the real part is equal to cos of So let's evaluate this integral. So it is the integral of t goes from 0 to 2 pi. Then we have cos 2t. Then we have I times e to the power of it. Okay. How to solve this? So what you do is you change everything to complex. Okay? So instead of writing in this way, you want the real part of z square. And z square was this one, e to the power it. So the real part of any complex number is equal to this number plus its conjugate divided by 2. So you write it as e to the power of 2it plus e to the power of minus 2it divided by 2. This will also give you cos of 2t. But this will be easier to integrate. So put this here. Okay? Right, everyone? Okay. So I'm going to do that. Okay, so we have the integral from 0 to 2 pi. Then we have e to the power of 2it plus e to the power of minus 2it divided by 2 I times e to the power of it d. So that is the integral that you have to solve. Okay, so the first one is I times the integral from 0 to 2 pi, and you can also take out the 2, e to the power of 3it dt. Then you have plus I divided by 2, the integral from 0 to 2 pi, e to the power of minus it. Okay? Alright, everyone? So the first one is I divided by 2 into 3i e to the power of 3it evaluated between 0 to 2 pi. The next one is I over 2 into minus it e to the power of minus it, so minus I evaluated between 0 to 2 pi. So the antiderivative of e to the power of 3it is 1 over 3i e to the power of 3it. Okay? You just use the same formulas that you use for real. Keep using the same formulas. A now is complex, it is 3i and also minus I. Okay? So keep using the same formulas. Everyone okay? Alright. So now plug in. E to the power of 3it evaluated at 2 pi, so you get 6 pi I minus e to the power of 0. How much is this? How much is this? Cos of 6 pi plus I times sine of 6 pi minus 1. So cos of 6 pi is 1. Cos of 6 pi is 1. Cos of 6 pi is?
Below, right?
And sine of 6 pi is 0. Okay, so this is 1 minus 1.
Lupa.
Benda kosong, tak tahu benda kosong.
Betul.
Apa jawapan aku ni kosong?
And also similarly, you can integrate now to get 0.
Tak formula, tak jawapan.
Rasa macam solution kan jalan kira berarti equal 0. Record je.
Ini tu.
Use Cauchy's integral theorem to evaluate the last question, please. To evaluate the integral dz over z square plus 1, where c is the contour of the curve z minus I equals to 1 in the complex plane, taken counterclockwise. first thing you have to do is to determine the residues and the singularities here. Okay? So this one is equal to the integral over the circle z over z minus I and z plus I. Yes or not, everyone? So now let's look at the circle. Okay? The circle is centered at I and has radius 1. So it is going like this in the counterclockwise direction. This is C. And where is the other singularity? It is at minus I. Okay? So the only singularity here is the one with I. So this part is the singularity. So by Cauchy's theorem integral formula, this is 2 pi I of fz evaluated at the singularity which is I. Yes or no? Cauchy's integral formula, no? Is this okay? Is this okay?
No.
Cauchy's integral formula? Cauchy's integral formula is that an integral over C from fz dz over z minus z0 is equal to 2 pi I into f evaluated at z0. Where z0 is the singularity inside of C. Here my f is this function here, 1 over z plus I. So 2 pi I f evaluated at the value of the singularity, which is I. Okay? So this would be, so this one will be equal to 2 pi I over d pi. So this is pi.
Tu jawapan dia.
Tu je jawapan dia.
Tu je.
Tu ke jawapan dia?
Mana potong dah.
Okay, can some people please help me out?